Now, this is all related to how we can fix our app in the browser. But what about our native app? For this, I'll close my server and I'll run ionic capacitor run Android-L here to start with Android debugging. Now, as you learned in the last module, this command will start our development server. It will also start up our Android Studio, and it will connect Android Studio or the native app we have there and our development server. So this is all done for us. And all we need to do then is, once this is done starting up here, we just have to launch this app on one of our simulators. So I'll launch it here. Select any simulator of your choice, and that will therefore then start. And once it is started, it will hold your application. This is still the old one. Let's wait for the new one to compile and start, because that's then the one connected to our live reload server. And here it is. Now, how could we see our console log here? We don't see it in the browser for this native app there. We only see the one of the browser application. How do we see our console log for the native app? Well, here in Android Studio, if you go to the Run tab down there, you see an output about your running application. Now, there you see a lot of messages, and it can be hard to find your own console log statements, but you will eventually see it. Here it is. There you see our data. That is our console log statement in the end, which is in there amongst all the other statements. And if you're having problems seeing it clearly, what you can always do, of course, just a little trick, you can throw in a console log statement with big fat capital letters, loaded recipes. So basically some identifier which you can easily spot in your log there. And that will then help you find the other log if you place that good spottable log right in front of the one you're interested in. So here it's reloading, and once it did reload, here we now see loaded recipes. That's a bit easier to see. We also see it here, and then here is our output. So console log statements can be seen there too. A bit harder to see, but you can still identify them here. What about breakpoints or detailed inspection? Well, for Android apps, Chrome helps you with that. You can visit chrome://inspect in your browser, in your Chrome browser, and that will open up a page where you should actually see your web app here on your emulator. Here it also says emulator. And this would even work for a real device connected to your machine if it is set up with USB debugging and so on. Now here you can click inspect. This should open up a new window where you now are connected to your Ionic app running in your native device. And here you see the console log output in a nicer way for this app now, not for the one in the browser, but for the real native app here. And you can also use all the other features you are used to. So here you have your network tab for outgoing requests from that native device app here. You can inspect your source code, and you can also set breakpoints there. So here, if I dive into my Webpack folder, into recipes and then recipe detail, in there, if I set a breakpoint in, let's say here, after I fetched my recipe ID, if I now go back here on the native device and I go back in, this gets paused again and I can inspect this, but now that is the code running in the native device. So we basically have the same tools also for performance, memory, and the elements that we know from the browser, but now for the native app. And that, of course, really helps with debugging native apps. But that's Android. What about iOS?